Alright, ladies and gentlemen, this video will go over the solutions to the periodic table dissection activity that we worked on Friday and over the weekend. So we're going to click on the assignment here, and there's the instructional video for how to do the activity. Remember, you should have printed this out and then followed these instructions. So let's take a look at the actual periodic table. Get it a little straighter here. All right. So numbers for groups, starting left to right, group 1, 2, 3 through 12, 13 through 18. I'm going to label hydrogen up here because that is an element that is going to stand alone. We'll explain why it's there when we get into the electron configurations piece later on. But for right now, that is not included in the group 1 name, because all of these elements that get named and grouped together here, lithium through francium, are called the alkali, A-L-K-A-L-I. Those are the alkali metals, and each one of those has one valence electron, one electron on its outermost energy level. And if you remember, we talked about this, and hydrogen would actually participate in this as well. It has a +1 charge. Okay. The second group is called the alkaline earth metals. Alkaline earth. That's A-L-K. A-L-I-N-E. Alkaline earth. And those are metals as well. They have 2 electrons on their outermost energy level. If you remember from the activity we went over on Thursday, the building an atom activity, every element that was in group 2 had 2 electrons on its outermost energy level. And because of that, they always get a +2 charge. In the middle here, in the middle, this block of elements 3 through 12, which I'm going to just put a highlighted line around this whole block here. So that would be 3 all the way over to 12. This block of elements is referred to as our transition metals. And in general, all of the transition metals have 2 valence electrons as well. Okay? Now, the difference here is that the charge, the ion charge, varies. So we have to look to the Roman numerals. Remember, we needed Roman numerals for those elements, with the exceptions of silver, which is always a +1, cadmium, which is a +2, zinc, which is a +2, and then boron is always a +3, and aluminum is always a +3. Okay? Now, the next group of elements I told you I needed you to put a name in for were group 16. Group 16 is called the chalcogens. C-H-A-L-C-O-G-E-N-S. The chalcogens. Okay? Group 17 is referred to as the halogens. H-A-L-O-G-E-N-S. And our last group here are the noble gases. The noble gases. Elements in column 13 have 3 valence electrons, and as far as the charge goes, boron and aluminum have a +3, but then these guys down below could have a variety of charges. So this group, we do want to write in plus or minus 4 because there are 4 valence electrons, and it could gain 1, 2, 3, 4 to become like a noble gas, or it could lose 4 to become like a noble gas. So depending on if it gains or loses, it'll be either plus or minus 4. Group 15, the nonmetals here are all -3s. The nonmetals here are all -2s. The nonmetals here are all -1. And the noble gases don't gain or lose, so they have a charge of 0. Group 15 has 5 valence electrons. Group 16 has 6 valence electrons. 17 has 7 valence electrons, and the noble gases have 8 valence electrons. The metalloid staircase goes stepping down through the elements like this. And everything to the left is a metal. Everything to the right is a nonmetal. Okay? Next thing I asked you to do was to highlight your 7 metalloids. That would be these 5 blocks on top. 1, 2, 3, 4, 5 on top. And then these 2 blocks, the germanium and the antimony, on the bottom. The last piece that we need to address, which we already named last time, are our lanthanides. And our actinides. Our lanthanides and our actinides. And this whole entire group as well, they all have 2 valence electrons, and their charges vary as well. So, as we look at our periodic table here, we have our alkali metals, group 1. Group 2 are alkaline earth. We have our transition metals. They are the 3 to 12 block. We'll learn that that's called the D block in our next discussion. We have our lanthanides and actinides, which is called our F block. And these guys actually fit. If we would mark where they go on the table, they go right here and right here. They fit in between those 2 columns. We break the table open, and these guys slide up in there. Okay, and you should be able to make sense of that with the way that the atomic numbers work out. Okay? Now, we will add some other information to this as we go through the remainder of the electron configurations piece. There's one section of metals down here. So all of these guys here, we simply refer to as other metals. And all of these up here, we just refer to as the other non-metals. The reason that we have a hard time giving group names to groups 13, 14, and 15 is because we have a mixture of metalloids and metals, or non-metals, metalloids, and metals. And to be honest with you, the chalcogens really only refers to these elements above the staircase. The chalcogens are all just the nonmetals here, and they have a -2 charge. These guys down here have multiple charges. The halogens go to the staircase and then have a -1 charge. This element here does not have a -1 charge. It is a metal. -3 would go for these three elements. These guys have multiple charges. Okay? All right. We will go through what causes the charges and why the table has the shape that it does in the next lesson. So stay tuned and check your check the module for the instruction and the instruction video for the next lesson. Remember, the conference will be used for Q&A so that you guys and gals can come and get your questions answered as you're working through the activities while we are remote.